Right now, at this very moment, something extraordinary is happening in our cosmic neighborhood. A visitor from another star system, a wanderer that has traveled for nearly 1 billion years through the cold, dark depths of interstellar space, is racing through our solar system at a mind-bending 130,000 miles per hour. But here's where it gets absolutely wild. This mysterious object, known as 3I Atlas, isn't just passing through, it's erupting. Its surface is dotted with ice volcanoes, cryovolcanoes, violently spewing frozen material into space as it swings around our sun. And scientists are absolutely stunned by what they're seeing. Before we dive into the ice volcanoes and what makes this object so incredibly special, let's set the stage. 3I Atlas was first spotted on July 1st, 2025 by the Atlas Survey System. That's the Asteroid Terrestrial-impact Last Alert System. But this wasn't just another comet. Within weeks of its discovery, astronomers confirmed something extraordinary. This object didn't originate in our solar system. It came from somewhere else in the galaxy. Now you might be thinking, okay, cool, but haven't we seen interstellar objects before? And you'd be absolutely right. 3I Atlas is actually the third confirmed interstellar visitor we've ever detected. The 3I in its name literally means third interstellar object. The first was the now famous Oumuamua, discovered in 2017. Remember that cigar-shaped mystery that sparked all those alien spaceship theories? Then came 2 I/Borisov in 2019, which looked and behaved much more like a typical comet. And now, in 2025, we have 3 I.ATL. But here's the thing, we're still not exactly sure how big 3 I. Atlas actually is. Based on observations from the Hubble Space Telescope taken in August 2025, astronomers estimate that its nucleus, its solid core, measures somewhere between 1,400 feet and 3.5 miles across. That's a huge range, right? It's the difference between a small mountain and a decent-sized city. The uncertainty exists because this comet is incredibly active, shrouded in a massive cloud of gas and dust that makes precise measurements challenging. Late October 2025 marked a critical moment in 3 IATLAS's journey through our solar system. On October 29th, this interstellar visitor reached perihelion, that's the closest point in its orbit to the sun, at a distance of about 1.36 astronomical units. To put that in perspective, that's about 126 million miles, or roughly between the orbits of Earth and Mars. Now here's where things get really interesting. As 3 IATLAS approached the sun, something remarkable happened, something that astronomers weren't entirely prepared for. The intense solar radiation began heating up the comet's surface, and it responded in spectacular fashion. Enormous jets of gas and dust erupted from its nucleus, streaming out into space like cosmic geysers. These jets stretched out behind the comet, forming a magnificent tail millions of miles long. But scientists observed something unusual. There was also an anti-tail, a tail-like structure that appeared to point toward the sun. This isn't uncommon in comets, but it's always a striking visual phenomenon caused by the geometry of how we observe the dust trail. This is where our story takes a truly unexpected turn. Dr. Josep Trigo Rodriguez and his team at the Institute of Space Sciences in Spain were observing 3 IATLAS during its perihelion passage using the Joan Oro telescope at the Montsec Observatory. They were capturing detailed images of those jets I mentioned, the gas and dust being released from the comet's surface. And what they found shocked them. The patterns they observed weren't consistent with typical comet outgassing. Instead, the evidence strongly suggested something far more dramatic: cryovolcanism, ice volcanoes actively erupting on the surface of an interstellar comet. We were all surprised. Being a comet formed in a remote planetary system, it is remarkable that the mixture of materials forming the surface of the body has resemblance with trans-Neptunian objects, bodies formed at a large distance from the sun but belonging to our planetary system. Let me break down what this means, because it's absolutely mind-blowing. When most of us think of volcanoes, we picture molten rock, lava, explosive eruptions, basically really hot stuff. But cryovolcanoes are the opposite. They're ice volcanoes that erupt frozen material materials like water, ammonia, methane, or carbon dioxide instead of molten rock. We've seen cryovolcanoes before in our own solar system. Saturn's moon Enceladus famously shoots out enormous plumes of water ice from its south pole. Jupiter's moon Europa likely has them too. Even Pluto showed evidence of cryovolcanic features when New Horizons flew by in 2015. But finding active cryovolcanism on an interstellar comet? That's unprecedented. That's new territory. So how do these ice volcanoes work on 3I ATLAS? According to Trigo Rodriguez and his team's research, which is currently undergoing peer review, here's the theory. Inside 3I ATLAS, there's frozen carbon dioxide ice. As the comet approaches the sun and heats up, this CO2 ice begins to sublimate. That means it transforms directly from solid ice to gas without becoming liquid. But here's where it gets chemically interesting. The researchers propose that this sublimating carbon dioxide is reacting with metals in the comet's core, specifically nickel and iron sulfides. This reaction causes these metals to oxidize, releasing energy. This internal heat source creates pressure that drives the cryovolcanic eruptions we're observing. It's essentially a cosmic chemistry experiment happening in real time, powered by the sun's heat and the comet's own composition. Now here's what has scientists truly excited and puzzled. The spectral analysis of 3I Atlas reveals something unexpected. Its surface composition is remarkably similar to trans-Neptunian objects from our own solar system. Trans-Neptunian objects, or TNOS, are chunks of rock and ice that orbit in the far reaches of our solar system, beyond Neptune's orbit, in a region called the Kuiper Belt. These are primitive bodies, leftovers from the formation of our solar system, barely touched by the sun's warmth for 4.6 billion years. 3I Atlas shows spectral similarities, suggesting it's a primitive carbonaceous object rich in carbon-based materials, likely enriched with native metals and undergoing significant chemical changes as it's exposed to our sun for the first time in its existence. Think about what this means. A comet that formed around a completely different star in a planetary system light years away has a composition similar to objects in the outer reaches of our solar system. This tells us something profound. The processes that formed planetary systems, our solar system, and the one where 3I Atlas originated might be more universal than we thought. The building blocks of planetary systems, the chemistry, the physics, these might be remarkably consistent across the galaxy. It's like finding a rock from another country that has the same composition as rocks from your backyard. It suggests that the fundamental geological processes might be similar everywhere. Let's take a moment to appreciate the incredible journey of this cosmic wanderer. According to research by Harvard astronomer Avi Loeb and his colleagues, 3I ATLAS has been traveling through interstellar space for approximately 800 million years. That's not a typo. 800 million years. To put that in perspective, when 3I ATLAS began its journey, Earth was in the late Cryogenian period. There were no plants on land, no animals, just simple multicellular organisms in the oceans. The entire evolutionary leap from those simple organisms to you watching this video happened while 3I Atlas was silently drifting through the void between stars. It traveled alone through the darkness, never feeling the warmth of a star, frozen to temperatures just a few degrees above absolute zero. Until this year, when it entered our solar system and finally, after nearly a billion years, felt the heat of a sun once again. And it responded by erupting. Here's the thing, we're in a golden window of opportunity right now. 3I ATLAS passed its closest point to the sun on October the 29th. And on December 19th, 2025, that's just weeks away from now, it will make its closest approach to Earth, passing at a distance of about 170 million miles. That's about 1.8 astronomical units. Now, before you get too excited, 3I Atlas won't be visible to the naked eye. You'll need a small telescope or binoculars to spot it. But the good news is that it will remain observable through spring 2026 as it continues its journey outward. NASA and space agencies around the world are pulling out all the stops to study this rare visitor. The Hubble Space Telescope, the Swift Observatory, and numerous ground-based observatories are all trained on 3I Atlas, gathering as much data as possible. Because opportunities like this don't come around around often, literally. You might be wondering, why does this matter? Why should we care about a comet from another star system? Let me tell you why this is absolutely crucial. Studying interstellar objects like 3I, ATLAS gives us a window into other planetary systems. We can't travel to other star systems. Not yet, anyway. The nearest star system, Alpha Centauri, is over 4 light years away. With our current technology, it would take tens of thousands of years to get there. But interstellar objects, they come to us. Every measurement we take, every spectrum we analyze, every image we capture tells us something about how planets form around other stars. The composition of 3I Atlas reveals what materials were available in that distant planetary system. The cryovolcanism tells us about the internal chemistry and structure. As Trigo Rodriguez and his team wrote in their paper, interstellar visitors like 3ATLAS continue to challenge and refine our understanding of planetary system formation and the chemical evolution of small bodies. Each newly discovered object reveals unexpected properties that test and expand current models. Well, here's where things get really exciting for the future. Scientists are already planning for the next interstellar visitor. The ESA's Hera spacecraft, launched in October 2024, represents the most sophisticated planetary defense probe we've ever built. While its primary mission is asteroid defense, it's also a testbed for technologies that could intercept future interstellar objects. Imagine this: the next time we detect an interstellar visitor entering our solar system, we could send a spacecraft to actually rendezvous with it, to fly alongside it, to land on it, to collect samples and bring them back to Earth. That's not science fiction. That's the next logical step. And the research being done on 3IATLAS right now is laying the groundwork for those future missions. As the research team concluded in their paper, future intercept missions will be essential for visiting and directly sampling these rare messengers and unlocking the record they carry from distant planetary systems. Let's zoom out for a moment and think about what 3I Atlas represents in the bigger picture. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Many, probably most, of those stars have planetary systems of their own, and those planetary systems are producing debris, comets, asteroids, fragments of planets that get ejected into interstellar space. Some estimates suggest there could be trillions upon trillions of interstellar objects drifting through our galaxy at any given moment. A cosmic ocean of wanderers, each one carrying the chemical fingerprints of its home system. 3I Atlas is just one of these countless wanderers. But it's special because it happened to pass close enough to our sun for us to detect it. And because we have the technology, the telescopes, the spacecraft, the scientific knowledge to study it. Think about this. Just 100 years ago, we didn't even know that other galaxies existed. We thought the Milky Way was the entire universe. Now we're studying objects from other star systems, analyzing their composition, watching ice volcanoes erupt on their surfaces in real time. That's extraordinary. So what happens next for our interstellar visitor? After its close approach to Earth on December 19th, 3IATLAS will continue on its journey. In March 2026, it will pass relatively close to Jupiter before exiting the solar system entirely, and then it will return to the cold, dark depths of interstellar space. It will travel for millions, possibly billions more years, never again feeling the warmth of our sun. Perhaps it will eventually enter another planetary system. Perhaps it will drift forever through the void. But the data we've gathered, the observations we've made, the knowledge we've gained that stays with us, the images of those erupting ice volcanoes, the spectral analysis revealing its composition, the insights into planetary formation in distant star systems. 3I Atlas may be leaving, but its legacy remains. If you have access to a telescope or binoculars, I strongly encourage you to try to observe 3I Atlas over the coming weeks. It's in the constellation Virgo right now, and there are plenty of finder charts and tracking tools available online to help you locate it. When you look at that tiny point of light through your telescope, remember, you're looking at an object that has traveled through interstellar space for 800 million years. You're seeing ice volcanoes erupting on the surface of a visitor from another star system. You're witnessing a moment in cosmic history that will never be repeated. This is what makes space exploration, astronomy, and planetary science so incredibly important. Every discovery challenges what we think we know. Every observation reveals reveals new mysteries. Every interstellar visitor reminds us that we live in a vast, dynamic, interconnected galaxy. 3. I-Atlas came from the depths of space, erupted in spectacular fashion as it swung around our sun, and will soon return to the cosmic ocean from which it came. But for a brief, shining moment, it was ours to study, and what we've learned will echo through astronomy for generations. Sometimes the universe sends us messages in the form of wandering ice and rock, and sometimes, if we're paying attention, we're ready to listen. Special thanks, Dr. Josep Trigo Rodriguez and the research team at the Institute of Space Sciences, Spain.